Okay, guys, so I know this is not the ideal situation, but this is the situation that we're in. And so I'm going to give you some notes on 3.1. It says it right here. Okay. Done. 3.1 notes. Okay. So just to start you out, this section is going to talk about critical values and extrema. Okay, critical values and extrema. Let me go and give you some information. Critical values happen when the derivative is set equal to 0. So I just wrote the derivative equals 0. That's where critical values happen. Extrema, gang, is just a fancy word for maximums and minimums. And just to break it down even further, you and I both know that this is an example of a minimum and this is an example of a maximum. And so those are two big ideas that we're going to talk about in this section, okay? And so to start us off, I'm going to draw you a picture of a basic quadratic, okay? So I've got a quadratic here. It obviously has a minimum, okay? That's college algebra kind of stuff, so now let's talk about calculus. Let's call this quadratic f of x, okay? And so now I need you to remember that the definition of a derivative, just to be reminded, a derivative is the slope of the tangent line. So I'm going to draw the slopes of the tangent line in red. So take a look here. Oh, that's the highlighter. Take a look here. So, okay, over here, I have a tangent line. I have a tangent line. I have a tangent line. All of those are tangent line, guys. And what kind of line is this? That's a negative slope line, a negative slope line, and a negative slope line. And so if you take a look, I'm going to change colors back. But over here, as f of x is decreasing, like obviously I'm going down, 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 down. The original graph is decreasing. My derivatives right here are negative. And so that's one of the big ideas. It says if the derivative is less than 0, and I need y'all to know that less than 0 obviously means negative. So if the derivative is negative, that means f of x is decreasing. And I just proved that to you up there. Okay? So that's a big idea. Another big idea, take a look at the other side of the parabola, guys. So over here, we can see that I have a positive tangent line, a positive tangent line, a positive tangent line. So positive slope, positive slope, positive slope. And if I go back, when I have a positive slope, f of x is not increasing, f of x is not decreasing, f of x is increasing. Take a look. This graph is going up, 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 up. And the tangent lines right here, tangent line, tangent line, tangent line, are positive, positive, and positive. And so if I go back, what does that mean? If the derivative, guys, is greater than 0, again, guys, you got to know greater than 0 means positive, then f of x is going to be increasing. Okay, those are two big ideas. The last idea, okay, so I've talked about what happens when the derivative is negative and what happens when the derivative is positive. But guys, hey, derivatives can also be equal to 0. And if I come up here and I show you, get that red marker out again, right here, guys. If I draw this line right here, you know from college algebra, this line is not increasing and it is also not decreasing. That is a slope of 0, which means the derivative equals 0. And so hopefully you realize, gang, that if the derivative equals 0, then f of x, then f of x, hold on, you got to bear with me, f of x is going to be a maximum or a minimum. And again, if I use the new word, it's going to be an extrema. And extrema happen at critical values. There's those two words that I talked about earlier. Okay, and so now I need to try to make this make sense to you. I know, again, this is hard, but we're going to make it work. So if I draw some fancy cubic, if you look at the graph using common sense, we have a maximum and we have a minimum. You can clearly see that, okay? Maximum and a minimum. So let's talk about the tangent lines again. So, hey, the tangent line is positive, positive, positive. And then the tangent line turns into a negative, negative, negative. So if the derivative goes from greater than 0, which means positive, to the derivative turns into a negative. Okay, take a look. Derivative is positive, positive, positive. Derivative is negative, negative, negative. Then your critical value is a max. Okay, and then if I get another color out, I'm really trying, guys. If I get another color out, okay, take a look. My derivative was negative, 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 negative. So the derivative was negative. And it changed to, okay, look, the derivative is now positive, positive, positive. The derivative is now positive. Then the critical value is a minimum. Okay, so I think I covered what I needed to cover in the notes. And so now I'm going to go into example 1, guys. So example 1 of the PowerPoint gives us this problem. Let me make sure I got it up. Yep, the problem is f of x equals 2x cubed minus 3x squared minus 12x plus 12. And the directions say find extrema. And again, guys, extrema means a max or min. And then it wants us to graph it. And we're going to do that. That's why I have graph paper as the background. Okay. Okay, so again, extrema happen at critical values. And critical values happen when we set the derivative equal to 0. So I'm going to find the derivative, guys. Okay, let's do it. Find the derivative. So the derivative of this is going to be 6x squared minus 6x minus 12. Okay, that's a basic derivative problem. And then we're going to take that bad boy and we're going to set him equal to 0. And now I need you to know algebra. So you should know this is a quadratic. Quadratics need to be factored, which means pull out the GCF. Okay. And we're still factoring. We're not done factoring. So if I set up my parentheses to factor, x times x, we know is x squared. I need numbers that multiply to get negative 2 and add to get an imaginary negative 1. So that's minus 2 and plus 1. And now you know to set all of your factors equal to 0. And if we set them equal to 0, guys, 6 doesn't equal 0. That's stupid. Here we add 2 to both sides. We get x equals 2. Here we subtract 1 on both sides. X equals negative 1. And so you may say, what did you just find, though, Miss Floyd? Well, these two things are my critical values. And again, critical values are extrema, which means these two things are going to be either a max or they're going to be a min, okay? And so, guys, now if I set this up, and I do this a little bit differently than to help me solve on my math lab, but we've got negative 1 is somewhere, and we've got 2. So this is a number line. We've got negative 1 and 2. And remember, the derivative will tell us if the function is increasing or decreasing. And so I'm going to test this interval. This is interval 1. I'm going to test this interval. This is interval 2. And I'm going to test this interval. This is interval 3 on my number line. And I'm going to figure out if the derivative is positive or if the derivative is negative. Okay, so I like to organize this into a chart. My chart is always the same thing. Interval comes first. And so my first interval right here, this interval that I'm looking at, is negative infinity to negative 1. My second interval is from negative 1 right here to 2. And my third interval is from 2 to infinity. And now in my table, I like to pick a test value because I need to test this thing and figure out if the derivative is positive or negative. So what is a number in between negative infinity and negative 1? Well, an easy number is negative 2. Negative 2 is in between negative infinity and negative 1. I usually get the question in class, do I have to pick negative 2? No, you can pick negative 3, negative 4, negative 5, negative 6. I don't care as long as it's in between negative infinity and negative 1. Now on the second interval, I need you to pick a test value that's in between negative 1 and 2. So you could pick 0 or 1 or any decimal in there. I'm going to choose 0. And then the last interval, guys, is 2 to infinity. Well, what's the number in between 2 and infinity? 3, 4, 5, 6. I'm going to choose 3. And I'm going to take these test values and I'm going to plug them in to the first derivative. And be reminded, the derivative, f prime of x, equaled, and I'm going to run out of room, 6x squared minus 6x minus 12. That was the first derivative. And so I'm going, let me actually get some more room. I can show all the work. The derivative was 6x squared minus 6x minus 12. So the first number I'm going to plug in is negative 2 because that was my first test value. So I get 6 times negative 2 squared minus 6 times negative 2 minus 12. Okay? Negative 2 squared is 4. 4 times 6 is 24. Negative times a negative is a positive. What is that? A positive 12. And then minus 12. So, guys, if you add these three numbers together, you get 24. I don't care that it's 24. I care that it's positive. Why do I care that it's positive? Because if it's positive, and I'm going to go on down to what this means. The meaning. That's the fourth thing of my chart. Okay? So the meaning. Because the number was positive, that means in this interval from negative infinity to negative 1, that the derivative is positive. And if you go back up here, guys, if the derivative was positive, look, derivative was positive, derivative positive, derivative was positive, the graph was increasing. So that means if the derivative is positive, f is increasing. Okay, so now we go do it again, but now I plug in the number 0. So it'll be 6 times 0 squared minus 6 times 0 minus 12. Well, guys, 0 squared is 0. 0 times 6 is 0. This is another 0 minus 12. And so we get negative 12. Again, I don't care that it's negative 12. I care that it's negative. And so that means in between negative 1 and 2, the entire interval is negative. And if the entire interval is negative, that means the function is decreasing. And then last but not least, you guessed it, we're going to go plug in 3. So it'll be 6 times 3 squared minus 6 times 3 minus 12. So let's do it. 3 squared is 9. 9 times 6 is 54. Minus 18. Minus 12. And if you do that, that's 30. That would be 24. Again, I don't care that it's 24. I care that it is positive. And if it is positive, that means f is increasing. Okay? So, let's think about this, guys. Let me get another color so I can hopefully make this make sense. If I'm increasing and then I start decreasing, I don't want that to happen. If I'm increasing and now I'm decreasing, I clearly have a maximum, which means -1, x equals -1 is a maximum. How do I know? Because I went from increasing to decreasing, which means maximum. Now let's go on the other side. Over here, I am decreasing, but then over here I start doing what? Increasing. So, let me get another color again. At 2, I went from decreasing to increasing, which means I'm going to have a minimum, which means x equals 2 is a minimum. All right, and now last but not least, and I would make this a real big deal if we were in class. Guys, maximum and minimums are ordered pairs. Big idea. These two things are ordered pairs. And you and I both know that ordered pairs consist of an x and a y. Well, you have x, but you don't have y. And at the very beginning of this class, you know that I tried to teach you that if I gave you x, you can plug back in and get your y. So if you go back, the last step, f of x originally was 2x cubed minus 3x squared. What was it? 2x cubed, there it was. 2x cubed minus 3x squared minus 12x plus 12. Minus 12x plus 12. And if you know x is -1, by golly, plug in -1. So it'll be 2 -1 cubed minus 3 -1 squared minus 12 times -1 plus 12. All right, so let's do this arithmetic. -1 cubed is -1. -1 times 2 is -2. -1 squared is a +1 times -3 is -3. Negative times negative is a +12 plus 12 more. So this is 24. This is -5. So put that together, you get positive 19. And so what's the ordered pair? -1, 19 is a maximum. That's extremal 1. Okay. Now, f of 2, because the second x value was 2. 2 times 2 cubed minus 3 times 2 squared minus 12 times 2 plus 12. 2 cubed is 8. 8 times 2 is 16, guys. 2 squared is 4 times -3 is -12. -24 plus 12. The -12 and the +12 will cancel, and 16 minus 24 is -8. So when you plug in a 2, you get out a -8. And you already told me that 2 is a minimum, which means 2/8 is really the minimum. And so that's what my math lab wants, guys. It wants the max, it wants the min, and then the next thing is going to want us to graph it. And so if I briefly sketch this thing. Okay, -1, let's say this is -1, all the way up to 19, there's going to be a maximum. At 2, let's say this is 1, 2. At 2, -8, let's say this is -8, we have a minimum. And if you go back up, guys, to my little handy-dandy table, the function starts increasing, and then it goes to decreasing. So I'm increasing, and then I'm decreasing, and then I'm what? Increasing. So come back down here. I am increasing, I am decreasing, and then I am increasing. So it's going to look something like that. That is a very ugly sketch, but that is an idea. Okay, so I really hope that this lesson helps. Good luck. Don't forget that you can message me if you need help. Thanks, guys.